Access points. Think of the wireless access point, or WAP, as the bridge between the physical and the invisible, while a switch provides connectivity through copper cables. The access point acts as a portal that converts those electrical signals into radio waves, allowing your mobile devices to join the wired network. To truly master the access point, you must understand the difference between an autonomous host and a lightweight controller-based system, and the vital role of the SSID. The bridge, Layer 2 connectivity. An access point is primarily a Layer 2 device. Its job is relatively simple. It takes data frames from the Ethernet cable and translates them into the 802.11 wireless standards we explored earlier. When you connect to an access point, you are effectively plugging into the switch that sits behind it, just without the wire. The access point maintains a table of every wireless device currently connected to it, ensuring that data meant for your smartphone doesn't get broadcast to everyone else's tablet. The logical identity, the SSID. The most visible part of an access point is the SSID, or Service Set Identifier. This is the name of the network that you see when you search for Wi-Fi on your phone. A professional access point can broadcast multiple SSIDs simultaneously. This is a critical tool for network segmentation. You might have one SSID named Corporate Secure that requires a username and password and gives access to internal servers on the same physical hardware. You might have a second SSID named Guest Internet that is isolated from the rest of the company. Behind the scenes, the access point tags the traffic from each SSID with a different VLAN ID, ensuring the data stays separated as it travels back to the switch. Autonomous versus lightweight access points. In your career, you will encounter two very different ways to manage these devices. Autonomous access points are standalone units. Each one is an independent host with its own configuration, security settings, and management interface. This is fine if you only have one or two units in a small office. However, if you have a massive campus with 500 access points, managing them individually is impossible if you want to change the Wi-Fi password. You would have to log into every single one manually. Lightweight access points are designed for the enterprise. These units have no brain of their own. Instead, they are managed by a central wireless LAN controller, or WLC when you change a setting on the controller. It automatically pushes that change out to every access point in the building instantly. This allows for advanced features like seamless roaming, where your laptop can move from one end of the building to the other, jumping between different access points without ever dropping your video call. Power over Ethernet, PoE. Because access points are usually mounted high on walls or on ceilings for the best signal coverage, finding a power outlet can be difficult. To solve this, professional access points use PoE, or Power over Ethernet. The same Ethernet cable that carries the data also carries the electricity needed to run the device. This power is usually provided by the managed switch we discussed earlier. This makes installation much cleaner and allows you to reboot a stuck access point simply by turning the power off and on at the switch port in the server room. Security, the invisible perimeter. From a cybersecurity perspective, the access point is a high-risk entry point because its signal bleeds out into the parking lot or the street. Modern access points use WPA3 encryption to protect the data in the air. Furthermore, they can perform rogue access point detection. The access point constantly scans the air for other Wi-Fi signals. If it sees a fake router that is trying to impersonate your office network to steal passwords, it can alert the administrator or even perform a deauthentication attack to prevent your employees from accidentally connecting to the hacker's device. Troubleshooting, coverage, and interference. When a user complains that the Wi-Fi is weak, the problem is usually placement, as we learned with the 6 GHz band. High-frequency radio waves are easily blocked by metal, concrete, and even large groups of people. As a technician, You will use a site survey tool to look for dead zones where the signal is too low. You might also check for channel overlap, ensuring that your access points are not fighting with each other on the same frequency. By carefully balancing the power levels and channel assignments, you can create a honeycomb of coverage that provides a fast, stable connection everywhere in the building. By mastering the coordination between lightweight access points and their controllers, you will be prepared to manage the wireless infrastructure for thousands of users across a massive enterprise.